All right, here we have example A for segments from chords. Asks us to find x in each diagram below. So for our first question here, we need to find the length of segment x, which runs from right here at this intersection down here to this point on the outside of the circle. And what we know, based on our theorem that we just discussed in the instruction above, is that the distance from here to here multiplied by the distance from here to here would be the same as, oops, sorry, I need another color, would be the same as this distance multiplied by this distance. So we know that 12 times 8 is equal to 10 times x. Well, 12 times 8 is 96, and if that's equal to 10 times x, then we can divide both sides by 10. So we just move this decimal over 1, right? Gives us 9.6 is equal to x. So that tells us that our missing little segment down here is 9.6 units long. Pretty straightforward. This one here, very similar. We know that 9 times 5 is equal to 15 times x. So we have 9 times 5 equals 15x. 9 times 5 is 45. Divide both sides by 15. And cancels here. 45 divided by 15 is 3 equals x. So that tells us that our missing unit right here is 3. Cool. All right, example B. Example B starts off very similar again, asks us to find a missing value. So we're supposed to solve for x. Well, x here is part of an expression, but other than that, it's the same situation we just had. We have 8 times 24 is equal to 12 times 3x plus 1. So we'll write that out. 8 times 24 equals 12 times 3x plus 1. Yeah, 12 times 3x plus 1. Now, because this is in parentheses, this makes this act as if it's a single number, right? So we could actually do at this point, that's kind of a neat trick, is to divide both sides by 12 right away. If we do that, divide this side by 12, that 12 cancels. And if we divide this side by 12, well, 12 and 24 reduce, right? 12 goes into 24 twice. So that leaves us 8 times 2 on top, or 16, equals 3x plus 1. And that was a lot easier than multiplying 8 times 24 and then dividing that by 12 when we were done, right? So now we just subtract 1 from both sides. We get 15 equals 3x. And divide both sides by 5, which by 3, which gives us 5 equals x. So our missing value here, x, is equal to 5 units, and this little length right here would be 5 times 3, or 15, plus 1, which is 16 units. Yeah? And then over here, we have this section right here, x minus 9, multiplied by 24, is the same as x minus 5, multiplied by 21. So let's grab a different color, and we'll have x minus 9 times 24 is equal to x minus 5 times 21. Yeah? So we'll go ahead, these are in parentheses, we'll go ahead and distribute those. So we have 24 times x, that's 24x, and 24 times 9, which is 216, minus 216 equals 21x, and 105. And we'll add that 105 to both sides. On the right-hand side, that'll cancel, of course. On the left-hand side, we get 111. So now we have 24x minus 111 equals 21x. And then we'll subtract 21x from both sides. Gives us 3x over here. Add 111 to both sides. Gives us 111 on the other side. And then we just take 111 divided by 3, which gives us, oops, did that one wrong. 111, clear. 111 divided by 3 equals 37. There we go. X equals 37. All right. And then finally for our last example, this one I thought was pretty cool. It says Ishmael found a broken piece of CD in his car. He placed a ruler across 2 points on the rim, and the length of the chord that he measured was 9.5 centimeters. So the distance from one side of his CD where he found, where it was broken off, to the other side of the CD was 9.5 centimeters. And then from the middle of the CD, where the middle of the broken part of the CD, to the edge was 1.75 centimeters. So right down through here. Now what we need to do is find the diameter of the entire CD. Well, what's pretty slick about that is we know that from here to here represents a chord. And if we have from the center of that chord, the midpoint of that chord, 90-degree angle to the side of the CD, we form another portion of a chord. But this line then, if this meets at 90 degrees to any one chord, this line is right on the center of the circle and would become the diameter of the CD if it were extended across. So that means we can take that information, take our 9.5 and split it in half, because we know that thing hits the midpoint now. Move on top here, that line right up to the center hits the midpoint. And we know that 4.25 times 4.25 is going to be equal to 1.75 times x, just like the last two things we've done, right? So that's kind of cool. So we have 4 1/4 times 4 1/4 equals 1.75 times x. And that gives us, what, 4 1/4 squared? It's going to be 18 1/16. So we'll just say about 18. 18 equals 1.75x. So if we take 18 and divide it by 1 3/4, 18 divided by 1.75 gives us just a little over 10, about 10 and 10.3 we'll say. So then x is equal to about 10.3 centimeters. So that's this distance from here to here. And we already had about 1 2/3, 1 3/4 centimeter. So we're looking at just about 10.3 plus 1.75 is just about 12 centimeters. And that actually is the width of a CD if you measure from top to bottom. And he found that just from having this little teeny tiny chunk that he picked up that was all broken off down here. He just had this little bit, and he could figure out what the diameter of the entire CD was just with that little bit of information. That's pretty cool.